Let's talk about sleep and sleep disorders. When we talk about sleep, it's imperative that you recognize what normal sleep is all about. So let's review the characteristics of sleep. Sleep is divided into two main stages. You've got non-REM and you've got REM, and they're both exact opposites. So when you look at the non-REM characteristics, what you're going to find is a slowing of the EEG, a lot of muscle tone, no eye movements, and basically no thought-like mental activity. So in the non-REM brain, what you have is that the brain is inactive, but the body is very active. The non-REM stages are divided into four. So you have stages 1, 2, 3, and 4. Now, what you need to be aware of is what stage of sleep is associated with what wave. So if you look at stage 1, what you have is the disappearance of the alpha, which is nothing more than a drowsy wave. But the main wave of stage 1 is the theta wave, and this makes up about 5% of total sleep time. Stage 2 are the K complexes and sleep spindles, which make up about 45% of sleep time. This, of course, is the largest of all the sleep stages. Stages 3 and 4 are made up of delta. Delta is a very slow wave. There's more delta in stage 4 than in stage 3. So stages 3 and 4 also make up about 25% of total sleep time. The average adult sleeps anywhere from 6 to 8 hours. So this percent is what that makes up of that 6 to 8 hours for each person. REM, of course, you're going to have a lot of EEG activity because that's when you're dreaming. That's where men are going to have penile erection. That's where you're going to have eye movements, but your body basically is not moving. So in REM, the only part that's active is your brain, but your body is inactive. And of course, the stages of REM are associated with sawtooth waves, and REM makes up about 25% of total sleep time. When we look at some sleep facts, you already know that stage 2 is the longest. So about 45% is made up of stage 2. Stages 3 and 4 are very slow because that's where the delta wave is. So stages 3 and 4 are also called delta sleep or slow wave sleep. Also, stages 3 and 4 are the deepest stages of sleep, so they're very hard to arouse someone if they are in one of these stages. REM, on the other hand, is very easy to arouse because it's a very light stage. And what you need to remember about REM is that you're going to find more REM in the second half of the night, whereas you're going to find more non-REM in the first half of the night. And as the night progresses, REM is going to be getting longer and longer, so that the first REM of the night is approximately 10 to 15 minutes, and the last REM of the night is approximately 20 to 40 minutes. Now, there are two concepts that you have to be familiar with: REM latency and sleep latency. REM latency occurs from the moment you fall asleep to the very first REM period, and that's an average of about 90 minutes. Now, there are two things that you need to be aware of that are due to shortened REM latency. One is depression, and in depression, most patients are in REM sleep in about 60 minutes, and number two is narcolepsy. So you're in REM in approximately less than 10 minutes. Sleep latency is from the moment you're awake till you immediately fall asleep. Now again, the average adult spends anywhere from 5, 10 to 15 minutes in sleep latency. The night before the exam, for example, where you have so much anxiety, you would imagine that sleep latency increases. But what if you were to take sleep medicines tonight? What sleep meds do is that they shorten sleep latency, so therefore you fall asleep faster. Now, as we get older, certain things happen to us. And the bottom line is that everything tends to decrease. When we talk about total sleep time, that tends to decrease. The baby sleeps about 16 hours a night. Adolescents sleep 8 to 10 hours a night. The average adult spends 6 to 8 hours a night. And the average elderly spends about 6 hours a night sleeping. So the overall trend is a reduction in total sleep time. Same thing applies for REM. The baby spends 50%. Adolescents and adults spend about 25%, and the elderly spend about 20% of their total sleep time in the REM part. So again, REM goes down. And of course, non-REM also decreases because stages 3 and 4 tend to decrease in the elderly to the point where they actually disappear. Now, the neurotransmitters of sleep are 4. It's serotonin, acetylcholine, norepinephrine, and dopamine. And the way to remember them is the mnemonic SAND. S for serotonin, A for acetylcholine, N for norepi, and D for dopamine. So anything that increases serotonin will initiate sleep. Anything that increases acetylcholine will produce REM. Anything that reduces norepinephrine will produce REM, and anything that increases dopamine will produce arousal and wakefulness. If you play with certain chemicals, of course, some of these will be affected. For example, tryptophan is a precursor of serotonin. So by giving the patient tryptophan, as is found in milk or turkey, what should happen? Patients will fall asleep faster and they'll sleep for longer periods of time. Dopamine agonists like bromocriptine, since we are producing the arousal, patients will tend to sleep less. If you were to take dopamine antagonists like haloperidol, what happens? The patients do not have that dopamine action, the patients do not have that arousal, so therefore the patients will be sleeping more. Now what the benzos do is that they tend to suppress stage 4 and they also shorten sleep latency. So when you stop the benzos abruptly, what typically happens is that patients will go into benzo withdrawal and sleep latency is increased. So instead of having the patient fall asleep within 5-10 minutes, it might take them 15 to 20 minutes to fall asleep. Now both alcohol and barbiturate intoxication both suppress REM. So you will have a patient who is dreaming less often. But if you are in alcohol or barbiturate withdrawal, what typically happens is that you have a REM rebound. So the brain will make up for some of the REM that it has already lost. Now for major depression, what typically happens is that you're going to have shortened REM latency, so it's from 90 minutes to 60 minutes. You're going to have an increase in REM time, especially that very first one. You're going to have multiple episodes of awakening as well as early morning awakening, and a lot of times you're going to have the suppression of that delta sleep, which is stages 3 and 4. Let's review the normal sleep architecture. So here you have the hours of sleep. So this is an individual who basically slept for 8 hours. And here from awake, stage 1 and REM, stage 2, and delta, you have the stages of sleep. Delta being, of course, the deepest stage of sleep. So delta is the deepest stage of sleep, which is, remember, stages 3 and 4. Now here you have an individual who is lying awake, then goes to sleep and enters the sleep cycle. So he enters into stage 1, stage 2, delta 2, and here we have the very first REM of the night. Each one of these dark shaded boxes is considered a REM. So this individual had 1, 2, 3, 4, 5, 6 REMs this night. Anything that is not shaded in would be a stage 1. So this would be stage 1. So all of these would be stage 2. So let's review some of the other facts that I went over. You know that there's more REM in the second half of the night instead of the first half of the night. So we're going to divide the night in two. So here we have the 4-hour mark as the half. Here you have the first half of the night with 2 REMs versus 1, 2, 3, 4 REMs in the second half of the night. You also have more non-REM in the first half of the night, whereas you don't have any non-REM in the second half of the night. And if you do, you have very little. So therefore, more non-REM in the first half, more REM in the second half. REM latency is the first REM of the night, and on average that's about 90 minutes. So if we go down, you'll see that about 90 minutes, this is when the patient first had their REM episode. And this line right here is sleep latency. This is the time necessary for you to actually fall asleep. So if this patient had insomnia, what you would expect to find is that this sleep latency line would of course be shifted. So it would be much wider, meaning that this is a person that is taking a longer time to fall asleep. I told you REM is the lightest of all the stages. So here we have REM and here we have awake. So as you can see, there's not much as far as what is needed to reach being awake. Whereas stages 3, 4 or delta, it's very deep, so you have to go all this far in order to go to being awakened. That's a basic review of sleep architecture. As far as the different waves associated with sleep, I would never expect them to ask this on a step 2.